Alright, so in this video we're going to be looking at comparing the mean and the standard deviation in two sets of data. Now the key thing to remember here is this is the exact same as when we compared data with the median and the semi-interquartile range. So in this case we now use that word average for when we're dealing with the mean, whereas before average was for our median. And we still use this term consistent or consistency for our standard deviation, whereas before we did it with the semi-interquartile range. And the whole structure of these sentences is the exact same as before. We must have our context, we must use those terminologies, and we must have a numerical comparison to justify what we are trying to say. So let's take a look at a couple of examples then. So to start off with, I have a group wants to see the effect of a targeted support study group in a course. They tested a class before the support study and after. Before, the mean was 53% with a standard deviation of 21.5, and after, the mean was 67% with a standard deviation of 15.8. So remember, we're wanting to compare the effects with our mean and the effects with our standard deviation. So let's first compare the mean. So comparing the mean, I want to say on average, the group scored more, because in this case our mean has increased. So on average, the group scored more after, since 67% is more than 53%. So again, using that word average, having it in the context and saying what is occurring, and then our numerical comparison. So let's do our standard deviation now. So remember, standard deviation, it's the same idea as semi-interquartile range. It is a measure to see how close my numbers are, how close my data is to the mean. So the smaller the number, the closer it is, and therefore the more consistent it is. So we can see our standard deviation has decreased after, so that means it's going to be more consistent. So I'd say the consistency of results after has increased, since 15.8 is less than 21.5. And again, you can structure these in slightly different ways. So I could always say the results of the test after was more consistent. So that's another way I could change that wording. But again, I still got to use that correct terminology, got to have that context, and got to have that numerical comparison. So let's take a look at one more then. So here I have a group of people attended a course to help them stop smoking. The following table shows the statistics before and after the course. So make two valid comments about these results. So first, let's take a look at that mean section. So I would say, so we're dealing with the number of cigarettes smoked per person per day. So I'd say, don't know why that zoomed in. The average, and I've got to write out that whole thing of what I am talking about. So the average number of cigarettes smoked per person per day has decreased after the course, since that 9.6 is less than that 20.8. So it's quite a fair bit I need to write for my context in this one, but I do need to include what the whole thing is about. So the average number of cigarettes smoked per day per person has decreased after the course, since 9.6 is less than that 20.8. So then comparing my standard deviation, so this time, actually after it's increased, so that means it's going to be less consistent now. So I'd say, sorry, my pen's being a bit weird. Let's just do that, see if that's helped. So the number of cigarettes smoked per person per day is, in this case, it's less than consistent. After the course, since that 12.0 is more than 8.5. Just about squeeze that in. So again, I must use the correct terminology, using that word average and consistent or consistency, putting it in the context and then having that numerical comparison. But again, the statements here are the exact same as what you've done before with the median and the semi-interquartile range, and the wording also translates, so those terminologies also are the same ones you use. Let me know if you have any questions, and good luck with the work.